Something is happening beneath Africa right now that scientists have never caught in the act before. Not anywhere on Earth, not in the entire history of modern geology. A study published on April 23, 2026 in Nature Communications by researchers at Columbia University's Lamont Doherty Earth Observatory delivered a finding so significant that the geophysicist who co-authored it did not reach for cautious academic language to describe it. She said simply, "We have reached that critical threshold of crustal breakdown. We think this is why it is more prone to separate." That statement refers to the Turkana Rift in Kenya and Ethiopia, a roughly 500-kilometer wide geological zone that the April 2026 study confirmed has now crossed into a phase called necking, the stage where continental crust thins past the point of no return, where the material stretching between two diverging tectonic plates becomes so thin and so weak that complete continental breakup is not just possible, but inevitable. Until this study, no active rift on Earth had ever been confirmed in the necking phase while it was still happening. Scientists had only ever studied necking in dead geology, the frozen remains of rifts that had already completed their breakup and gone cold millions of years ago. The Turkana Rift is the first place in the world where this critical phase can be measured as it unfolds in real time, and that is only the beginning of what Africa is revealing in 2026 about the hidden story of our planet and the civilizations that lived on it before recorded history ever began. The crust along the rift's axis in the Turkana region is now approximately 13 kilometers thick compared to the average crustal depth of 39 kilometers found elsewhere. That is not a modest thinning. That is a reduction of 2/3, bringing the crust to a thickness that, in the language of geophysics, constitutes a structural failure waiting to complete itself. The Turkana Rift did not reach this stage through a single continuous process. The region was stretched twice by two separate rift systems running in different directions. The older Central African rift system pulled the crust in one direction from the Mesozoic into the early Cenozoic. Then the East African rift system began pulling it north to south roughly 40 to 45 million years ago. What made the difference was timing. Less than 17 million years separated the end of the first episode from the start of the second. Too short an interval for lithospheric healing, the slow process by which crust restiffens after being stretched and heated. The second round of rifting hit crust that had never fully recovered, and intense volcanism compounded the weakening. The lead author of the study described the thinning process with a comparison that makes the physics immediately intuitive. It is like pulling saltwater taffy from both ends. The middle next down elongates and becomes the weakest point. The thinner the crust gets, the weaker it becomes, and the weaker it becomes, the more it promotes continued rifting. The process accelerates its own outcome. To fully grasp what the April 2286 finding means, you need to understand what the East African rift system actually is, because the Turkana Rift is one segment of a vastly larger geological story that has been unfolding for tens of millions of years across the full length of a continent. The East African rift system extends over thousands of kilometers. North of the Afar Triple Junction, the rift follows two paths, west to the Red Sea Rift and east to the Aden Ridge in the Gulf of Aden. Southward from the Afar Triple Junction, the East African Rift consists of two main branches. The Eastern Rift Valley runs southward from the Afar Triple Junction and continues south as the Kenyan Rift Valley into northern Tanzania. The Western Rift Valley transects the Democratic Republic of the Congo, Uganda, Rwanda, and Burundi through the Ruzizi Plain, and farther south, Tanzania, Zambia, the valley of Lake Malawi, and Mozambique. The entire system stretches more than 3,000 kilometers from the Afar Depression in northeastern Ethiopia down to Mozambique in the south. It marks the boundary where the African tectonic plate is in the process of splitting into two separate plates. The Nubian plate to the west, which carries the bulk of the continent, including West Africa and the Sahara, and the Somali plate to the east, which carries the Horn of Africa, East Africa, and Madagascar. What has driven this splitting is now becoming clearer thanks to research published earlier in 2026. New research suggests that the East African Rift could be driven by a massive superplume rising from deep within the Earth's mantle. High-precision measurements of gases escaping from a geothermal field in Kenya's section of the Rift Valley, particularly their neon isotopes, revealed that they likely originated from a very deep source within the Earth's mantle. Even more intriguing was the discovery that the gases shared the same chemical signature as volcanic rocks found thousands of kilometers apart, from the Red Sea in the north to Malawi in the south. Such consistency across such vast distances strongly suggests a single massive source feeding volcanic activity throughout the entire region. A mantle, superplume, a colossal upwelling of hot material rooted near the boundary between the Earth's core and mantle. This superplume is, in essence, a column of extraordinarily hot rock rising from approximately 2,900 kilometers beneath the surface, delivering heat from near the Earth's core boundary all the way up to the underside of the African continental crust and systematically doming, stretching, and thinning the lithosphere across a geological canvas that covers multiple countries and takes tens of millions of years to complete one chapter. The surface expressions of this process are already visible to anyone who has stood in the East African Rift Valley. The landscape is defined by the geology underneath it, steep fault escarpments dropping hundreds of meters to rift basin floors, chains of volcanoes marking where magma has found pathways through fractured crust, and a series of long, narrow, extraordinarily deep lakes, Lake Tanganyika, Lake Malawi, Lake Turkana itself, that formed where the subsiding rift basins filled with water. Lake Tanganyika is the second deepest lake on Earth and the world's longest freshwater lake, stretching nearly 700 kilometers and reaching depths of almost 1,500 meters. It exists because the Earth's crust beneath it has been pulled apart and allowed to subside. These lakes are, in a geological sense, the embryonic beginning of a future ocean. The rift is still young, the water is still fresh, but the direction of travel is clear. And now something new has been added to this picture. A study of hot springs in Zambia's Kafue Rift found helium and carbon isotope signatures suggesting that mantle-derived fluids are reaching the surface. In other words, evidence of a new, younger rift system developing farther south than the known East African rift system. This finding, published in May 2026 in Frontiers in Earth Science, suggests that the rifting process may be propagating southward even faster than existing models predicted, with new segments of African continental crust beginning to stretch and thin at locations previously considered geologically stable. Researchers working in Zambia are already expanding their sampling area to test whether the helium signatures they found are part of a continuous mantle connectivity that extends across the full boundary zone between the Nubian and Somali plates. The data from that expanded survey are expected before the end of 2026. This is the geological layer of the Africa story in 2026, and it would be remarkable enough on its own. But the splitting of the continent is only one of the extraordinary things that Africa is revealing right now, and in some ways, not even the most unsettling one. Because beneath the sands of the Sahara Desert and beneath the canopy of the Congo Basin rainforest, a completely different kind of hidden history is coming into focus, one that involves not planetary geology, but human civilization, and one that is challenging assumptions so fundamental that archaeologists are describing the findings with a level of caution that itself signals how significant they consider what they are finding. Begin with the Sahara, because the Sahara that exists today, the largest hot desert on Earth covering approximately 9 million square kilometers of North Africa, a landscape of dunes and rock and almost total biological emptiness, is not the Sahara that existed for most of the time that modern humans have been on this planet. Between approximately 14,000 years ago and approximately 5,000 years ago, the region that is now the Sahara experienced what climate scientists call the African humid period, a climatological regime so dramatically different from today's conditions that the Sahara during this period was not a desert at all. It was a savanna, threaded with rivers, dotted with lakes, covered with grasses and trees, and populated by elephants, giraffes, hippopotamuses, crocodiles, and the full ecological community that today exists only south of the Sahara's modern borders. And it was populated by people, not nomadic wanderers in marginal numbers, but organized societies with agriculture, animal husbandry, complex social structures, and cultural practices sophisticated enough to leave an enduring artistic record. The rock art of the Tassili Niger Plateau in Algeria is the most visible surviving expression of those societies, with paintings and engravings depicting cattle herds, hunting scenes, fishing activity, and human figures that date back as far as 12,000 years. But the archaeological record is far richer and stranger than rock art alone. In the central Sahara, in regions like Fezzan in Libya and the Caucasus Mountains, researchers have discovered stone burial structures up to 9,000 years old, some circular, some built with concentric rings of stone, others in forms that suggest primitive pyramidal shapes. Inside these tombs, human remains were found interred alongside tools, shell ornaments, and red ochre pigments. One burial discovered in what is now Niger contained the skeletal remains of a woman with 2 children, her arms wrapped around them in what appears to be a deliberate embrace. The posture is not accidental arrangement. It is a statement about relationship and care, made by people who had concepts of family and loss and commemoration that were sophisticated enough to be expressed in the physical organization of a burial. These are not the remains of people on the margins of human development. These are the remains of people living complex lives in a complex society, in what is now the middle of the world's most inhospitable desert. What transformed the green Sahara into the desert that exists today is a mechanism that climate scientists call the precession feedback loop. And it is one of the more sobering examples of how planetary scale processes can collapse an entire biome with geological speed. The Earth's axis wobbles slowly over tens of thousands of years in a cycle called axial precession. Approximately 5,000 to 6,000 years ago, a shift in this precession changed the angle at which sunlight hit the northern hemisphere during summer months, weakening the West African monsoon system that had been delivering rainfall to North Africa. Less rainfall meant less vegetation. Less vegetation meant more of the land's surface reflecting solar energy back into space rather than absorbing it, a process called albedo feedback, which reduced local atmospheric heating, which reduced the convective processes that drive monsoon rainfall, which produced still less vegetation. The system did not gradually transition, it collapsed, and the collapse was faster than the geological record had led scientists to expect. Where there had been rivers and lakes and grasslands and human settlements for thousands of years, the desert arrived within a few centuries. The people who had been living in the Green Sahara had to go somewhere. The timing of the Sahara's collapse and the sudden crystallization of ancient Egyptian civilization along the Nile is not a coincidence that archaeologists have ignored. It is a connection that has been discussed, debated, and studied for decades, and the genetic and archaeological evidence continues to build toward a specific conclusion. Modern genetic analyses show that early North African populations carried a mixture of sub-Saharan and Near Eastern ancestry, consistent with long-distance contact across a habitable Sahara, exactly the kind of mobility that would have been possible and normal during the African humid period, and impossible after its end. The ancient Egyptian texts themselves contain what may be the most intriguing evidence of all. King lists inscribed at Abydos, at Turin, and recorded on the Palermo stone that extend backwards, not merely centuries, but according to some readings, tens of thousands of years, into a period that Egyptians themselves referred to as the time of the gods and the followers of Horus. The overwhelming consensus of Egyptology treats these pre-dynastic entries as mythological rather than historical. But the question of why a civilization would preserve detailed king lists extending back that far into a mythological period, and why those mythological periods show internally consistent chronological structure, has never been fully put to rest. What radar satellites have found beneath the Saharan sands adds another dimension to this question that goes beyond interpretation. Beneath the western Sahara Desert, satellite-borne radar systems operating at wavelengths that penetrate dry sand to depths of several meters have traced the fossilized bed of an ancient river that flowed during the African humid period. This river, known to researchers as the Tamanrasset River, once carried water from the southern slopes of the Atlas Mountains through what is now the Central Sahara to the Atlantic Ocean. Researchers estimate it was one of the largest rivers in North Africa during its active period, comparable in scale to the modern Niger River. Today, nothing remains visible at the surface. The river lies beneath hundreds of meters of sand in some places, detectable only as a ghostly signal in radar data, a scar in the continental crust from a hydrological system that sustained life across a landscape that now supports almost none. Under the right conditions, radar mapping across similar areas of the Sahara has revealed traces of ancient lake basins, dried stream beds, and in some cases, structural anomalies whose origin remains ambiguous. What those anomalies might preserve beneath the sand, whether they include built structures, carved inscriptions, or the physical remains of settlements, is a question that current technology can hint at but not yet answer. The situation in the Congo Basin is structurally different but archaeologically equally significant. The Congo rainforest is the second largest tropical forest on Earth, covering approximately 3 million square kilometers of Central Africa in a canopy so dense and an ecosystem so complex that it gives the impression of territory that has never been significantly altered by human activity. That impression is wrong, and the evidence that it is wrong is written directly into the soil. Scattered across the Congo Basin are patches of earth known to researchers as African dark earths. Soils whose chemical composition differs so dramatically from the surrounding tropical soil that the difference is immediately measurable. Typical tropical rainforest soils are extremely nutrient poor, heavily leached by rainfall, and unable to sustain productive agriculture without substantial external inputs. African dark earths are the opposite. They contain extraordinarily high concentrations of nitrogen, phosphorus, and calcium that have persisted for millennia. Analysis of their composition reveals that they are made up of charcoal, bone fragments, organic residues, and human waste, the specific combination of materials produced by dense, long-term human settlement. These soils did not form naturally. They formed because people lived in those places intensively for extended periods, modifying the soil chemistry through cooking fires and agricultural practice until the earth itself was permanently transformed. In some communities in Guinea, local people have a specific name for these soils, Tombondu, meaning the land of an ancient settlement. The knowledge that these dark fertile patches mark the locations of old human habitation was never entirely lost. It just was not known to outside researchers until systematic archaeology reached those regions. The implication is significant. Much of what we perceive as ancient, undisturbed Congo rainforest is in fact regenerated secondary forest that has grown back over the ruins of a densely populated landscape. The trees are real, the ecology is real, but the substrate underneath is anthropogenic, shaped by human activity over centuries, and the forest that looks primeval is growing on what was once inhabited ground. Archaeological data suggests that the Congo Basin experienced a sharp population collapse somewhere between 400 and 600 CE, the causes of which remain debated. Climate shifts, epidemics, or the combination of multiple stressors are all under consideration. Whatever the cause, settlements were abandoned and the forest took the land back. The dark earths remain as the primary evidence that those settlements existed. The climate implications of the Congo Basin's hidden human history are not merely archaeological. The Congo Basin holds one of the most important carbon reservoirs on the planet. Its vast peatlands and swamps store approximately 1/3 of the carbon captured in tropical peatlands worldwide, despite covering only 3% of the Earth's total land surface. Recent research has found that these ancient carbon stores are already beginning to release CO2 that has been locked in place for thousands of years. Studies of large dark water lakes in the Congo Basin found that up to 40% of the CO2 being emitted from those lakes to the atmosphere was coming not from recently decomposed organic matter, but from peat material thousands of years old. If climate change causes these peatlands to dry out, as models predict is increasingly likely under warming scenarios, bacteria will begin decomposing the ancient organic material, releasing stored carbon that has not been in the atmosphere since before the earliest human civilizations. The feedback loop that would result is not a distant hypothetical. It is a mechanism that climate scientists are already measuring the early stages of. There's one more structure in Africa that deserves a place in this story, and it occupies a strange position between geology and the human imagination. If you look at photographs of the Sahara Desert taken from the International Space Station, one feature stops every astronaut who sees it for the first time. In the Saharan Desert of Mauritania, a perfect circular structure approximately 50 kilometers in diameter appears in the sand, its concentric rings so geometrically precise that the immediate instinct of every person who sees it for the first time is that something deliberate created it. This is the reshape structure, known informally as the Eye of the Sahara, and it has generated more speculation about alien construction, lost civilizations, and Atlantis than almost any other geological feature on Earth. The Atlantis interpretation, in particular, circulates persistently. Plato's description of Atlantis as a central island surrounded by alternating rings of land and water matches the visual appearance of the reshape structure closely enough that the comparison has been made repeatedly and seriously by non-specialists. The geological explanation is both more prosaic and, on reflection, considerably more impressive. The reshape structure is an eroded geological dome. Approximately 100 million years ago, a massive bubble of molten rock pushed upward from below without reaching the surface, doming the overlying sedimentary layers into a raised circular structure. The magma never erupted, but it lifted the rock above it, and then over 100 million years, wind and water and sand went to work. The softer sedimentary layers eroded faster than the harder quartzite formations, which remained standing as tall ridges. The softer material between them was carved away into valleys. The result is a natural cross-section of the geological layers of the Earth's crust, peeled back concentrically by erosion over 100 million years to reveal the internal structure of what was once a subterranean dome. Some of the rock exposed at the surface of the reshape structure is 100 million years old. There are no signs of human construction within it. No walls, no ceramics, no tools. The concentric rings are real, the geometry is real, and the result is one of the most visually extraordinary geological formations on Earth. But it is a geological formation, not an archaeological one. What Africa is revealing in 2026, across all of these stories taken together, is something that geology and archaeology are only beginning to articulate clearly. The continent that most of the world associates primarily with its present, its current population, its current political boundaries, its current ecological crises, is simultaneously the site of the most advanced continental breakup event ever caught in real time. The location of a lost civilization-scale human presence in the Sahara, whose full extent is still buried under sand that radar is only beginning to penetrate, a Congo Basin rainforest that is not wilderness at all, but a regenerated landscape, growing over thousands of years of human habitation, and a geological record extending back billions of years that is still being read for the first time in many of its most important chapters. The Turkana Rift will continue to thin. The Nubian and Somali plates will continue to separate at roughly 4.7 millimeters per year. In a few million years, magma will rise between them and begin forming new oceanic crust. And landlocked nations that today have no coastline will find themselves on the shores of Earth's sixth ocean. The The dark earths of the Congo will continue to hold their chemical testimony to settlements that the forest has not quite managed to erase. The radar images of the Sahara will continue to suggest outlines of what lies beneath. And the Richat structure will continue to stare upward at passing satellites from its desert silence, 100 million years of erosion compressed into something that looks, from space, almost deliberately made. Africa is not revealing its secrets reluctantly. It is revealing them in real time, through peer-reviewed studies and satellite data and chemical isotopes in hot springs, to anyone paying close enough attention to notice that the continent is simultaneously disintegrating at its edges and uncovering the past it has been keeping underneath.